Hello, welcome to this week's episode of the Chemistry Made Simple podcast. I'm Matthew Macario from Chemistry Made Simple. This week we're talking about atomic structure. So in this episode we're going to be talking about why we need a more advanced atomic model than the one we've learnt so far. What are the differences between what we've learnt already and what we need to advance to now? And what concepts we need to introduce in order to make that leap. Firstly, we need to consider why we need to have a more advanced model at all. The basic model has some limitations. It only works for the basic concepts that we've learnt so far. It doesn't really explain the shape of the periodic table, for example. You will have learnt that from the second shell onwards, shells are able to accommodate up to 8 electrons. But if you look at the periodic table, you'll see that from the fourth period, from the fourth row down the periodic table, you begin to see more than 8 elements across the periodic table. In fact, you see 18 in the fourth period, and you see even more further down the periodic table. And because you already know that each consecutive element has one more electron than the previous element, you'll realise that that means there must be more than 8 electrons available in those shells. So we need to advance our model in order to be able to understand that. If there's 18 elements, of course, there must be room for 18 electrons in a shell to go across that period. Another issue is that the model that we've dealt with is very flat, it's very two-dimensional. Consider it as a solar system type model. So in our basic model so far, we've considered that around the nucleus of the atom, we have shells of electrons that orbit around that nucleus. In a very two-dimensional way, it's a very flat concept. One that's nice and easy to draw on a two-dimensional piece of paper, but doesn't actually reflect the three-dimensional nature of atoms. Let's make a comparison between the basic atomic model that you will have learnt so far, what I'm calling the Year 10 model here, and the Year 12 model, the more advanced model that you're learning now. In the basic model, we understood that the nucleus of an atom contains the protons and the neutrons, and we're not changing that concept. The nucleus does contain the protons and the neutrons. Our basic model, we considered that the first shell is able to accommodate up to 2 electrons, and that the second and subsequent shells are able to accommodate up to 8 electrons each. And the first part of that is true. The first shell is able to accommodate up to 2 electrons. The second shell of an atom is able to accommodate up to 8 electrons, but subsequent shells have space for more than 8 electrons. And actually, each subsequent shell has more capacity to accommodate electrons than the previous shell. There are no 2 shells of an atom that have the same capacity for electrons. In our basic model, we gave no consideration to any division of shells. We just considered that all the electrons in any shell had the same energy as each other and behaved in exactly the same way as each other as well. But we're going to introduce in this model the concept that electron shells are made up of orbitals, and actually the orbitals within a single electron shell can have slightly different energy and slightly different behaviour to each other. In summary, our basic model was fine for the basic concepts that we've considered in chemistry so far, and also for the first 20 elements on the periodic table. Certainly when we go beyond element 20 and we start looking at slightly more advanced concepts in chemistry, that we need to advance this model, and we can start to see the effect of more electron capacity per shell and the effect of having orbitals within shells. So what are these new concepts that we're introducing? Well, we've already mentioned that shells are comprised of orbitals, and that orbitals within a shell have electrons with slightly different energy levels and slightly different behaviour. It must follow that orbitals within a shell have to be different types to each other, and actually these have different shapes as well. And you'll come to be able to recognise and even sketch some of the basic shapes of some of the orbitals. And all these things are because we're now introducing the concept of quantum mechanics into the atomic model. In other words, we stop ignoring quantum mechanics. They're always there, always affecting the atom. We've just left them out of our model so far, but now we have to introduce them in order to start understanding some of the concepts of chemistry. So what is quantum mechanics? Well, it's a branch of physics It deals with the behaviour of extremely small particles, and in chemistry we're going to consider how quantum mechanics describes the behaviour of electrons in particular. Quantum mechanics can also be applied to many other small particles. It can be applied to atoms, it can be applied to photons, and many other very small particles. These particles have very counterintuitive behaviour and properties compared to the everyday world we see around us. We're going to focus on quantum mechanics in our next episode, so don't miss that. Coming back to our atomic structure model that we're going to be learning about now, it's a three-dimensional model, as opposed to the two-dimensional model that we talked about previously. So it copes with the shape of molecules, the angles of bonding, and so on. So it explains the layout of the periodic table and helps us understand how the D block and the F block can exist in the periodic table. It also considers the nature of electrons, and for that we require the quantum mechanics we've mentioned and the introduction of quantum numbers, which will help us understand a bit more about why those orbitals exist as well. If you'd like to see the accompanying notes to this episode, which include a diagram of the shapes of some of the orbitals and also a comparison of the atomic models you've learnt so far and what you're going to be learning from this point forward, then go to the show notes that are at chemistrymadesimple.net/2. In our next episode, we're going to be defining what quantum mechanics means for chemistry at this stage. We're also going to make this counterintuitive concept seem simpler, making it more like the world around us that we understand. So what would be good if you subscribe now, join us for that episode, and I'll speak to you then.